Hi everyone, welcome to Induscon 2021 in the section Industry Applications 2. My name is Milena Faria and I'm the chair of the session, and Professor Alexandre is the co-chair. During the presentations, the questions and comments will be done via YouTube and delivered to the presenters. I hope this interaction can be successfully done. In the first time of the session, we are going to see all short videos from the session. Then the authors will be on the screen to answer them. This session will be held in English and in Portuguese because we have papers in both languages. Professor Alexandre, good evening.
Good evening, Milena.
So let's start the session, and good luck for the authors.
One of the authors of An Economic Evaluation of an Intelligent Streetlight System for Smart Cities, published at Induscon 2021 Conference, I'm now going to give you a quick tour about this research. In the current scenario, turning on and off public lamps happens based only in the amount of light detected by a sensor. An intelligent system can allow public lighting to implement more complex strategies, such as brightness control. In this work, a low-cost intelligent module to be integrated with the public lighting is presented and evaluated from the technical and economical standpoints. A low-cost hardware capable of allowing the operation of a single lamppost is presented along with its software implementation. The module will read the environment lighting condition, such as humidity, temperature, and also the current and the voltage from the light bulb. This information will be used later in the software implementation to determine whether to change brightness from the light bulb. Authors evaluate the module feasibility by estimating the maximum amount of power possible that can still provide positive returns. The module economic evaluation was performed based on three parameters. First, considering only the module installation. Second, considering the retrofit of the module and the installation of a high-pressure sodium light bulb. And third, the retrofit of a mercury vapor light bulb and the module installation. Our results have showed viable economic return with a good payback time. These results allow the authors to conclude the module viability, and in the future, authors intend to evaluate the labor and installation costs, as well as more complex teaming strategies based on pedestrian and vehicle traffic. Authors are available for any doubt, and contact information can be found at the link. Thank you.
Hello everyone, my name is Yago Silva. I'm presenting you the low pressure line control for automatic pressure testing applied in oil and gas industry. The main objective here is to model and develop a control and automation to make pressure ramps using a low pressure system of an HPU. To achieve that, we used Hutlocus to model the PID controller. The overall idea is to set up the assembly, mechanical and controls part, understand the system, extracting a mathematical model from data acquired, and then configure the PLC, VFD, and supervisor to finally have the final test. In this part, we can see the pre-test to model the system, which it was acquired a profile curve for pressure and a profile curve for speed, and then make some analysis to understand and conclude some points. Some of them are listed here as a first order system. System has saturation, delay, and some estimate pose and gains. After that, it was set up this function transfer, which was found this function transfer, and build this block diagram to simulate the model and check if the model matches with the reality. As you can see, the pressure in blue and the speed in purple is very similar to the real system. During the simulations, to make sure that our controller is good enough to the system, we use that model and configure our PID after hood to locus analysis, and with P equals to 0.3 and I equals to 0.26 D 0.16, we have this response with pressure in blue, control signal in purple, and set point in green. It is good enough to be tested in real system. In the real system, as we expected, we have a good result with the set point in purple, and the blue line is the pressure. So all the set points being reached, and the springs are running. It is fair to conclude that the system has a great performance, with the results are very satisfactory, and proposed to automate the low pressure line has been achieved, matching the theory and the practical. I would like to thank CEFET-RJ, Agvs, CNPq, and FAPERJ for supporting this work. Thank you all.
This article is an interoperability case study between Agvs and Correlates in the production line. The consumption of contemporary society is based on the manufacture of products that need some industrial procedure to be obtained. This need for manufacturing has been present since the beginning of our organization societies, including the manufacture of artisans. The current production of goods and services is driven by phenomena such as a demand for customized products, energy efficiency, environmental impact, carbon footprint, and others. In this scenario, Industry 4.0 appears to be spreading a new industrial archetype, marked by a new level of social-technical interaction. Each small decentralized process in the factory is self-controlled and capable of responding to different situations autonomously. This article wants to show a case study of interoperability between Agv systems in a real production line and its corresponding optimization.
For the development of this project, a research was carried out to understand the automation process of a production line of a large company in the automotive sector, with great performance in the truck industry in Brazil. The research was aimed at simulating how an integration of autonomous systems would occur within the manufacturing process, in addition to understanding the needs of integrating systems in a production line with several automated systems, identifying how machines communicate and how they can be controlled through databases to perform simulations with the Programmable Logic Controller, or PLC.
Basically, what we did to elaborate this article is that we studied how a real production line works, what kind of systems it needs, and how the information flows into different equipments, and we studied the different protocols and different data types that come from different types of machines from different companies, and we try to put all this together in a virtual simulation environment and make this a tool so that we could study how to integrate all these systems and how it would work in a real-life system.
I'm Cody. Today I'll be talking about geometric accuracy and 3D printing resulting by selection of the process parameters in fused filament fabrication. My co-authors are Jörg Schneidler and Ahmad Barari, all from Ontario Tech University, from AD2M Labs. So say you have a new 3D printer and you want to improve the service quality and geometric accuracy of the parts coming off this printer. What's the best way of doing this? One of the ways you could do it, and the way we did it, was using design of experiments. So the first thing with this process is, which parameters do you want to modify? So we went with the feed rate, or the speed of the extruder, the extrusion temperature, the layer thickness, the infill, and the flow rate. Next, we want to figure out what the ranges and increments of these parameters are going to be. We need to make sure that we keep it to a reasonable number of prints, and it needs to be done in a small enough, relatively amount of time. So here are the values we went with. We went with a lower limit and an upper limit. So these are going to be the only two values we use for all parameters, and then we're going to go through all permutations of those values. And finally, we have our center point. We're going to run 5 center point runs dispersed throughout the rest of the runs, just as an average point. Those will not be subjected to any permutation. We also made 3 different test parts. So we have one for linear dimensions, circular dimensions, and angular dimensions. So results. After this process, we had much improved surface quality. Just through visual inspection alone, it's very easy to see how improved things are. So for example, with our 15% infill, regardless of other properties, we had these surface holes, which is just because the infill wasn't able to support the top layers. By increasing that to 35%, our upper limit, we now have much better top layers, and our surface quality is much better overall. We also have these unoptimized parts here, which through optimization, we have far superior parts, much less inaccuracy. So before we had an average deviation of 0.35 millimeters for any specific dimension, afterwards a deviation of 0.08 on average millimeters. So a great improvement. So what do we find out? Our feed rate and our flow rate are highly dependent on each other, which makes sense because the faster the nozzle moves, the more plastic you need to flow through it. The extrusion temperature also dealt with feed rate. The higher the temperature is, the faster that filament can come through, but with some other effects on geometric accuracy. Our layer thickness, which is well known, is very important for surface quality. The lower it is, the better, although it takes longer. And finally, the infill directly affects the quality of our top surfaces, as we saw a few slides ago. So in conclusion, DOE is an effective tool for determining these kinds of parameters. Geometric accuracy and service quality were improved greatly on our printer after our process tweaks. And in the future, we're going to look at how other parameters could influence part quality and how those may interact. Thank you.
My name is Guilherme Roveg. I'll present the short presentation of the paper entitled Discrete RMRAC Support Light Mode Structure for Current Regulation of Single-Phase Grid-Tie Converters with LCL Filter. The proposed controller is for current regulation of single-phase grid-tie converters with LCL filter. And we combine two structures, RMRAC and Super Twisted Light Mode, and we obtain results in PSIM, in software simulation, comparing it performance with a proportional resonant controller, classical controller, and RMRAC with an adaptive first-order light mode controller. This is the plant, LCL single-phase with a voltage source inverter. Okay, this is the complete. A general diagram block diagram with the control signal, control flow of the system, the proposed controller. We have the model reference, the plant, the recursive algorithm, and the control actions. That the complete control action is composed by the sum of RMRAC, super twisting, and the electrical grid as a periodic disturbance. We have the results that we compare. In 0.2 seconds, we have a load step from 50% to 100%. In 0.4 seconds, we have the weak grid environment when we add a considerable inductive term in the electrical grid. You can see that the classical controller was not able to keep the system regulated, but the adaptive controllers are able. We have the tracking error comparing the first order sliding mode RMRAC and the second order. We have the augmented error when we can see that the super twisted sliding mode presents a less value of error if we compare with the first order sliding mode. It occurs because the control action of the super twisting acts more specifically during the transit regime conversion to tending to zero in the steady state. The adaptive gains of the proposed structure are disturbed in the 0.2 seconds, 0.4, but it converts in steady state regime. So the proposed controller was able to keep the system regulated with good performance and stable. The classical controller was not able because the parametric variation was big to it considered. And we noted a chatter attenuation that reflected in the tracking error, augmented error, and in the quality of the system. We can SCAPs, Federal University of Santa Maria, GPOC, and feel free to send me an email, and we can discuss more about the theme. Thank you.
Essa é uma apresentação sobre a modernização de uma bancada de teste de FCU utilizando o LabVIEW. O Parque de Material Aeronáutico de São Paulo é a principal base de manutenção da Força Aérea. Nela, são realizadas inspeções de diferentes componentes das aeronaves, como motor, válvula governador de velocidade e a unidade de controle de combustível. A unidade de controle de combustível, também chamada de FCU, atua como intermediária entre o piloto e a válvula de combustível, garantindo que o controle de velocidade seja eficaz independentemente da altitude ou do nível de combustível. Para isso, o FCU usa o ângulo da alavanca de torque, a pressão de ar atmosférico e a pressão na bomba de combustível para determinar qual deve ser a vazão para o motor. A bancada de testes do FCU é parte da seção de teste de acessórios do PAMA. Ela simula condições de voo nas entradas do FCU e mede as variáveis intermediárias e de saída para garantir que estejam de acordo com os valores estipulados na documentação dos procedimentos de teste. Antes do retrofit, a bancada era composta de manômetros, botões e válvulas manuais, sendo que todos os controles e indicadores eram analógicos, com exceção do controle de velocidade do motor. Para realizar os procedimentos de teste, o operador precisava colocar manualmente os valores das variáveis e anotar os valores de cada um dos manômetros em um papel, repetindo esse processo para cada passo do procedimento. Este projeto foi desenvolvido inteiramente utilizando o LabVIEW. O LabVIEW é uma linguagem de programação gráfica com blocos de funções conectados através de fios com diferentes tipos de dados. Ele é ideal para sistemas complexos de controle e aquisição, já que seu grande nível de abstração permite programar rotinas com várias etapas em um curto período de tempo. Após o retrofit, o operador controla todas as entradas através de um teclado, com a possibilidade de controle automático durante o procedimento de teste. Os relatórios são gerados ao final do procedimento, e são separados em ano, mês e dia. Incluem o seu nome e o horário final do teste. Com essas melhorias, o tempo de teste foi reduzido, os erros humanos não são mais um problema, e todos os dados são organizados e acessíveis. Em seguida, será apresentada uma demonstração do controle da válvula de pressão de ar. Então a gente tinha aqui as válvulas antigas analógicas, e a gente colocou um controle nelas com um motor DC para deixá-las automáticas. Eu vou rodar aqui o programa para mostrar ela funcionando com o controle. Eu vou mandar para o set point de 30 e a válvula vai subir até 30. Então eu tenho aqui o gráfico da subida dela, funcionando normal. Ele tem um pouquinho de ruído, mas ele funciona com o controle sem problema nenhum.
So welcome back to the authors. Good evening all. Good evening to the audience in YouTube. The audience can send any questions in the chat box. And welcome to the authors to the Induscon 2021. We are going to proceed now to the questions. We are going to in the proceedings, okay? So the first paper is an economic evaluation of an intelligent streetlight system for smart cities context and applications. The presenter is Aurelio Gouveia from Federal University of Juiz de Fora. Hi, Aurelio. Congratulations for your work.
Hi. Hello, everyone.
Alexandre, do you have any questions?
Yes, I have a question. Did the authors consider, or are they considering, the issue of the cybersecurity in this research? Because the cybersecurity is an important thing. I thought this and reading your work.
Hi everyone again. Yes, in the current state, authors are not considering cybersecurity. We understand that this is an important issue. Once you have integrated lighting system public, for example, if it's available for anyone could connect to the post lamp and light up and light down things if they want to. So we understand that's very important, and it will be possible to test this type of question with the development of a system that is everything is open. But right now, ours have not considered it in this work that is presented at this conference. Maybe in future works, it's possible that we are going to test some strategies to provide security to the transmission and to the local lamp control system.
Okay, I think so. Your work is very interesting. The intelligence use of the power, illumination of etc. is a very good thing. But I really are worried. This type of
I believe there is some problem in the connection of Alexandre. Let's wait. Hi, Alexandre. Can you repeat the question? I think there is some problems of connectivity.
Oh, yes. But this your work is very good. I like it. The intelligence use of the power of the energy is a very good thing. But I really think with this type of systems, there are a possibility from, like I say, bad things. So I work worry about cyber security in this type of the infrastructure. Okay, but I like your work really.
Yeah, I understand your concern. We think that it's important to pursue things like the we are proposing in this work because right now you don't even see LED lighting systems. For example, still see in most public light systems conventional lamps, and that's a waste of energy. And with systems that can control the lighting, the public light system, we can also increase this power savings. But I understand your concern about cybersecurity. Yes, it's a very important thing, and but I think that the idea of the paper of developing an open platform that we can use despite the solutions, the custom solutions that we already have, will enable us to implement those type of tests in the future, in future works. And I think your question is very valid, and it will probably provide a good research paper in the future. I think it's inevitable that we are going to have to discuss that because the number of IoT systems, of intelligent systems connected in every house is growing at an impressive pace.
Okay, thank you.
So thank you very much, Aurelio, Alexandre, for the question. I hope it's not weird because I'm co-authoring this article, but can I proceed with a question? I will take advantage and in the answer of the Aurelio, and he told that it's not so conventional, and even we have some LED lamps. So most common lamps in the public light street is the conventional lamps. We don't see so much LED here in Brazil and in most of the developing countries. So we are talking here about costs, right? So just change conventional lamps to LED, we have an improvement in the costs. So regarding this, can you tell us about the cost of the prototype?
Yeah, first, the cost that we have in the paper is for the development of a single unit, and it gives us an idea about what is possible. But we understand that with mass manufacturing, these costs are going to be way down. We understand that outsourcing for China, for example, will bring the cost down. And we also expect that with more dedicated electronics, we may also be able to reduce power consumption and improve even the project ROI, return of investment.
Okay.
Okay, thank you very much. So now the authors have questions. We don't have questions on YouTube. So can we go to the next paper? Okay. So the second paper is low pressure line control for automatic pressure testing applied in oil and gas industry. The presenter is Yago Silva from CEFET. So Alexandre, we'll ask you again to do the questions because I'm also co-authoring this paper.
Okay, I have a question. Are the authors thinking of use some other PID tuning scheme, such a physics logic? I question this because I myself make very tests from PID syntony, and the physics logic show in these problems with our work superior. So I think the approach for Ziegler initials you used is valid. Perhaps there are other things more efficient. Okay.
Okay.
I put the question for writing here. Excuse me.
Okay.
Control C.
Good evening, everyone.
Control
My name is
V.
Yago. Thanks, Induscon, for having us. And about the implement other controllers with the PID was not covered in this paper. For future works, I think that it would be great to use an estimator to understand the the dynamic of the system and change the gains of the PID would be more efficient to this type of the control for low pressure for pressure in general, because pressure has no linear parts and some delays. So maybe if we have an estimator, a controller estimator, to understand the process better. But with fuzzy logic, I don't search for this, so I don't consider.
Okay, it's idea for
Yes,
future works.
yes, maybe could be better. It could be good approach. Uh, so
I like your work. So is don't understand this like a critical. Is not.
yeah,
It's a suggestion. Okay,
yeah,
to future
okay,
works.
An
yeah, sure.
idea for further improvement. Thank
Yes.
you.
Yes,
So I will ask a question regarding the experimental tests, because when we're talking about low pressure line control, this is very sensitive. So how do you proceed with these tests?
uh, the test was considered with the valve, so was empirical. Basically, most of the parts of the test, since the modeling to the tuning, because this is a very critical process. It's dangerous because pressure could kill us. So the tuning was made with small gains than the simulation provide us. So we simulate the gains, but in the practical part, it was more empirical to achieve that gains that we found in the simulation. I think I answered your question, but then if not, ask me again.
No, no, you did it because as you told, this is very dangerous.
Yeah.
So I know that there is some particulars and specific requirements to do this kind of test. So yeah, you answer well. I don't know if the other authors have some questions.
I take the cautions with the process, isolating the area and etc. But it still is a dangerous test.
Yeah,
No,
no, yes. Please, Alexandre.
one last question. You use it root locus scheme for uh, stability analysis. Uh, why not bold diagram, frequency diagram? Because why you use the root locus?
When I learned Hooch locus in the controls one in Cefet, I thought that I would never use it. So I decided to use Hooch locus to this analysis to improve to prove to me that Hooch locus it's a good method. It is a
Okay,
valid method for a practical approach.
okay.
There is not any particular motive to use Hooch locus. Just
I think so. In this work, gain margin, phase margin, it's an important parameter. It's another suggestion. Okay.
okay.
That's good.
Thanks.
Okay, great. I don't know if we have no questions on YouTube. I don't know if the authors wants to do a question for Yago. Okay, guys, I'm co-authoring. It's allowed to do questions to Yago. Don't worry. Okay, so let's proceed to the third paper of the session. So it's entitled Interoperability Case Study Between Agvs and Correlates in Production Line. The presenter is Jonas Onias from Federal University of ABC. Hi, Jonas.
Hello, everyone.
Okay, hello. Congratulations, Jonas, for your work. I will do a question here. Indeed, Industry 4.0 is spreading a new industrial archetype. And as Alexandre asked in the first paper here about security, this is a very important matter. And so the automatic guide vehicles an essential component in the industry and the intralogistic. I was wondering if you were studying something about the security in this kind of component.
Yeah, we didn't evaluate any kind of security in this project, but it is a matter that is growing every day. So, but the problem of security in this kind of study that we had is more of a software problem than an automation problem. We focus on the automation matter, and the part of security would be in a higher level in the scale. It would be the next step in the project, and in going in that direction, we could implement different types of data structures that could improve the security of all the automation and all the data in the whole system.
Okay, great. I saw that you developed a control movement to this autonomous vehicle using ladder programming. Was only testing ladder, or you already proceeding to another kind of simulation environment or in a practical experiment?
Yes, the idea before the COVID was trying it in the real life, but due to all the things that happened in the last year, we had to stop just in the simulation environment of Twitter. So we just testing the ladder environment.
I'm sorry, Milena. The COVID-19 it was a problem from this work. The use of the ladder diagram is my guilty. Okay, my guilty, because I professor from this in our days, and it's a very easy path to this work. And interesting thing about this work, the students have access to AGVs, industrial and operational AGVs. This type of data is difficult to have in the university, because it's a really real time working.
Okay, no, that's really nice. I was reading. Now I see your name there, so I'm going to ask you questions. I'm kidding.
I have no questions.
So I was wondering if you are already moving to some kind of realistic environment, because we are in your introduction you're talking about autonomous vehicles and this kind of components in the intralogistics field. So I was wondering, maybe they could try some realistic environment like
idea.
robotic operating system. I don't know if you know the ROS. So would be very nice to test this kind of control strategy in a more another kind of language, not just in ladder, but like C++ or Python, so you can proceed with more high-level languages. But very, very nice work. Any questions from the authors? No questions from YouTube?
Milena, it is
Yes.
possible to simulate with host and gazebo and other platform to simulate the environment with the AVG. It is.
It's possible, right?
Yeah, it is possible. Maybe it is good to see this application as host because of this, because you can simulate in a safety environment.
Okay, great.
It's a good idea, but the before the COVID, the idea was to a case study from Agvs in this company with my students working, Jonas and the fellow.
Paulo.
And Paulo, and COVID was here.
It came and stopped a lot of works.
Yes, yes. Delayed work, change plans, etc.
Okay. So if the other authors doesn't want to do questions to Alexandre, I'm kidding again. Alexandre, brief.
No.
So we can proceed to the other paper that is entitled Improving 3D Printing Geometric Accuracy Using Design of Experiments on Process Parameters in Fused Filament Fabrication. The presenter is Cody from Ontario Tech University. Hi, Cody.
Hi there.
I'm pronounced correctly? Okay, thank you. So congratulations, Cody. Your papers is really interesting. So as far as I understood, the outcome is a setting of selection, the processing parameters to achieve a higher geometric quality of parts, 3D parts, and a desired level of reproducibility, so using 3D printers. So I was thinking if this is just you need to use a specific printer for this selection of parameters, or can you do this in all kind of 3D printers?
So this is a very generic process. You can apply this to any 3D printer that you have. The only real concern there is with different filaments and different machines, your process parameters are likely going to be different. So this is more of a general overview of a process you could apply to any other machine. Our results are going to be very specific to our specific machine, our specific filament, and even the environmental conditions can have a factor in how your quality is going to end up.
Oh, that's really, really nice. Did you already have a correlation among the thickness, infill percentage, and top layers?
We did see a couple of correlations. So, for example, with the top layers and infill, the infill, of course, has to support everything on those top layers. So the smaller your infill percentages, the worse your top layer quality is going to be. Basically, in the presentation, you probably saw that there is filament falling through into the part. You had large holes in the top surface. And so there's always a cost-benefit analysis you have to do there. Do you care about those top surfaces, or do you care about the least amount of material being used? And so this can kind of get you towards that. You can kind of figure out where the edges between decent top surface quality and smallest percent infill. Other things like the filament flow rate and the temperature were also really important. They correlated with each other very well, because as you're trying to force more material through a nozzle of a very constant diameter, if you don't have the heat behind it, it's not going to flow. And so your part ends up looking terrible. So yes, there was a couple different correlations we did find there in terms of the parameters we set and the quality we ended up getting.
Oh, that's really nice. Yeah, for sure the temperature will be a problem. Yeah. So I think we have some questions. A question from YouTube, but from Professor Alexandre Acácio. Can you show us, Gianfranco?
No.
No, this one. The other one.
So no, we did not. We did not do that for this particular experiment. This was very much a setup for another experiment where I believe this had 37 experiments or something. We just wanted to figure out, what kind of quality you can get from this machine using some a very small number of experiments. We did go larger. I think we did something over 200 prints at the end of the day on a different experiment. But no, there was no statistical analysis in terms of how we determined what these factors were or what the statistical relevance was.
It's a suggestion to improving. Okay?
Yes, thank you.
So I am taking advantage from this suggestion. And so what is your next step regarding this paper?
So we went with 5 very easy to change parameters in this paper. We wanted to go more in depth in the number of parameters selected. So this was, very basic stuff that everyone can change very easily. But what about if your printer is built incorrectly? We used, this is a capstone project printer that we had on the team for a couple of years back. And they did a good job. But what if you're out of parallel? What if you're out of square? What's your tolerance in there that you can allow? Can we modify that to see what effect that's going to have on quality? More difficult parameters to modify are things we want to look at to see if we can maybe expand this and get more generic results for other printers without having to test 200 parts in every printer that comes into our lab. We want to just be able to measure and apply and hope we get the best quality possible.
Okay, thank you very much. Congratulations once again for your work. The other authors have some questions to Cody?
Just out of curiosity, have you thought about creating an app that the sub-user could look for some characteristics and put there and get the parameters for the specific type of printer?
I haven't, but that sounds really interesting, actually. That could be really useful for the 3D printing community. Of course, yeah. Everyone's always getting a new 3D printer these days, so just have something you could easily set up your printer day one and have a good print would definitely be a useful thing.
Yes,
for sure, I will buy it. Okay. Please, Aurelio, continue.
No, I was just make a remark. I think that it's something that I have seen. I have tried to 3D print some parts, and sometimes you have to make 2-3 times the same part to get some characteristics, resistance, weight, and you have to be changing many things at a time, and sometimes you don't even know what you are changing to get that result that you want. So it will be very nice to have a tool to do something like that.
Yeah, absolutely. Especially when you have like a 30-hour print and you finish it and you just wasted all that material. It's heartbreaking.
I know this is suffering, so we are here sharing. So now we have 2 buyers, Cody.
Sounds good.
So we have no questions on YouTube. Now we are going to proceed to the next paper, that is Discrete RMRAC-STSM structure for current regulation of single-phase grid-tied converters with LCL filter. So the presenter is Guilherme Vieira Roveg, Federal University of Santa Maria. Did I pronounce your surname correctly? Roveg.
Yeah, good afternoon. Yes, yeah, it's right. It's hard to follow, but it's this one.
Okay, so just I would like to do a question, Guilherme. So you aim to design a discrete robust model reference adaptive controller. Okay. Ooh.
Yes.
So use an adaptive super twist slide molding control. Yes. Okay. Is your work only done in simulation, or you already tested in a practical experimental analysis?
Yeah, this result is from my PhD thesis. So this paper is the preliminary result of my PhD thesis that with testing results of simulation. But now we have, I'm finishing my PhD, then we tested in the prototype, 5.5 kilowatt prototype, but the prototype that we tested the structure is a 3-phase grid-tied voltage source inverter, but in this paper it is a single phase. This is the main difference, but yes, we tested the proposed method in the experimental model, and this results were very interesting. Mainly in the shattering attenuation, because the superficial sliding mode, because it's used the derivative of the tracking error, not the sign of the tracking error, it eliminates the shattering, and the combination of RMRAC and the STSM controller. Of course, this is a new controller, but you have to prove mathematical that it's stable, not only the experimental results, but the results are very interesting even in the prototype.
Okay, great. And now that I know that you are going to defend your PhD, I must do questions to test if you're going to pass, right? So let me ask you about stability. You told us that is a stable controller. How do you test it? Because I didn't see here in the paper, I think.
No, in the paper, I did in the time I did not have the proofs, but yes, now I have, and it's all okay. I used the Lyapunov analysis to prove stability, so I chose a candidate function, and I proved even in the continuous time and in discrete time that the tracking error goes, it not goes to zero, but it goes around zero. It converts to a finite set of parameters, and since the phi that we use in the controller, that is the difference from the theta and theta, the real theta, and since the phi goes to zero, then my proposed controller, the adaptive controller, found a set of parameters that converts the system, and we can see this in the mathematical analysis too, not only in the experimental results.
Okay, great. So, so as far as understood, you already implement this in an experimental test. You have all the mathematical proof for stability. So, what is the stage now of your work? I was curious.
I qualified my PhD a few months ago, and I'm planning to defend my thesis in the end of this year, maybe December, or because I have the proofs. I have these results of the paper that is simulation, but I also tested in the hardware in the loop. I use the hardware in the loop to test before going to experimental, and in the experimental we have the similar results.
Okay, so did you compare your outcomes with all the conventional methods?
Yes, I compared with in this paper I compared with proportional resonance, but the proportional resonance was not able to keep the plant stable because my controller used a first order model reference, and we do not. If you see the plant, you see that we do not have the resistor of the damping resistor. So I'm not sure if this paper have this, but in my thesis,
you didn't. Okay, your thesis, but in the paper was not.
Yeah, that one, it was a preliminary result. It was at the beginning of the research, but the plant, the three-phase plant, would not use the damper resistor. So the controller have to be able to keep the system stable, well-regulated, without considering this damper resistor by means of efficiency. So the proportional resonance that we regulated was not using some active damping. So in another periodics, the revisor told me that if I propose an adaptive control system, I have to compare with adaptive control system. So today I do not compare with classical methods, but I compare with RMRAC, only the RMRAC, and RMRAC with the first order sliding mode. That is it's more simple because we use the sign of the tracking error. Of course, that is simple. It's simpler. The mathematical are simpler too, but the computational burden of my proposed structure is one of the drawbacks of the controller. because the super twisting requires more computational burden to compute the mathematical. Yes.
Yes. Okay. For me, it's okay. Alexandre, do you have questions?
I have a little bit from suggestion. I see in your paper you use bold diagram in 2 times, figure 4, figure 5, and I wonder if to stability analysis you can use this tool. In the MATLAB, when you use the bold diagram command, you can't you get the phase merging gain measure. This is stability point.
Yes.
Okay. So it's a suggestion. This archaic method from bold diagram, it's working. It's working. Okay. It's a simple and cheap means to see stability.
Yes, of course. I use the board diagrams in this paper more to follow to show the how it is the plant, how I chosen the model reference, how is different my model reference from the plant since it's simplified. But of course, I totally agree with you, Professor. Even for the classical computers, the board diagrams are a archaic system. But of course, cracking I'm not. Need to be evil, but it works, of course. But
okay, the power of classics.
Yeah, it works very well, but and of course it is some way to show the stability. I agree.
Okay.
Perfect. The authors have a question for Guilherme. Okay. Oh, you guys are very nice. So thank you, Guilherme. Congratulations once again for your work, and I wish you luck for your defense.
Okay, thank you.
So we now proceed to the last paper of this session, that is entitled, em português, Modernização de bancada de teste de FCU utilizando LabVIEW. The presenter is Victor Manuel Araújo de Almeida, from Instituto Federal de Educação, Ciência e Tecnologia de São Paulo. Hi, Victor.
Hello.
So your work is in Portuguese, but I talked before with Victor, and he told us that he can answer the questions in English, so can we all understand? Thank you and congratulations to your work, Victor. It's very interesting. I like it very much when you put the video and you show it's working. That's very nice. So this kind of process that you're trying to to put in automatic way is not is just manual process.
Yeah. Before we did the retrofit, it was completely manual. So you had analog indicators, and you had mechanic and electromechanic controls, and the operator had to manually look at each of the manometers and register their value by hand using a pen and paper, really. So the idea behind it was this is slow, this is unreliable, because if the operator doesn't register correctly, you can then look back in the test and say, well, that field control unit had no problems with it, but it could be just the operator not wanting to redo the test and marking as passed, So our idea was to expedite the process and to make it more reliable.
Okay, very, very nice. I was wondering the viability of turning this process in automatic way. Can you tell us?
Well, it was very simple, actually. We had two equipments from National Instruments and I. There was a compact reconfigurable I/O input and output. We call it serial. and compact data acquisition, we call CDAC, and the cards for each of those equipments. So in total, we spent about, I'd say, $50,000 in the process with the materials. And of course, the development of it was free because it was our conclusion work for the university. So in general, it was much cheaper than buying an off-the-shelf solution or sending to a private company to develop.
Okay, thank you. Okay.
Just a question. I see that National Instruments is a very common choice in many labs and things like that. But would be possible? Do you think that using Raspberry Pi and other more custom solutions? Because I think the cost will be way down than using equipment just such as the one you are using.
That's a very valid question because National Instruments equipments are very expensive. But what you get with it is extreme reliability. So we are working in an environment, as you could see from the video, we are working in an environment that it's very dirty. The installations from the base where we were working at are very old. They are from the 50s. So the electrical installations are not very reliable. So working with a Raspberry Pi, while cheaper, would both increase the time we took to develop, because LabVIEW is an amazing tool to develop an acquisition system. It's very fast. And it wouldn't be so reliable because Raspberry system would be very affected by the noise in the electrical system, the dirtiness of the environment and stuff like that.
Yeah, I understand. Thank you.
Thank you very much. So I think Alexandre put a question here for Victor.
Okay. Sorry by the Portuguese.
No, it's all right. I can read the question in English if need be. But essentially, you're suggesting working with private companies to develop a system in other places like that.
Yeah.
I can't say much about it, but because we are still in talks of doing that, I can say with what we're developing. But we are developing a very similar system for a different institution. But for that institution, we are developing the system from the ground up. So instead of retrofitting a system, we are developing it from nothing. And the idea is to make it even more automatic than it was for the aeronautics. So yeah, we are developing a system like that, and we are planning on developing systems for other aeronautics equipment.
Okay, thank you.
Thank you very much. Last question. So you stopped this kind of tests here, or did you did more experimental tests?
So at the time of sending the paper, we had only implemented the air pressure valve. So the test we see in the video is the air pressure valve, and we later developed the fuel pressure valve, and we developed completely the complete control of the system. Because when that video was filmed, only the data acquisition was in place, and there was no automatic control. The control was still done manually. So yeah, we developed a bit more, but it wasn't in time for the paper, so we couldn't send it.
Okay, thank you. Because you wrote in the future work that there is another way of reducing the time of the test. So I was wondering if you did more advanced things in your experiment.
Yeah, about that. We couldn't completely automate the system because there is a control, the torque control, the throttle control, that still has to be operated manually because we don't have an actuator for it. So in that project, we didn't develop an actuator for it. It's still manual. But in the other project we are developing from zero, we are planning on making an actuator for that the variable.
Okay, so using hardened loop solution.
Yep.
Okay, great. So thank you very much, Victor. We have another question, Alexandre.
No?
Authors, we have no question here from YouTube, and the authors want to do questions. Okay, so I think we have a question to the work of your work, Jonas. Can you show us here, Jean, the question regarding the LiDAR? Okay. Actually, is the suggestion here. So, Jonas, can you answer this question, or actually the suggestion?
Yes, that is what we were talking about, that we could actually implement a lot of things that we did in Ladder. We could use like Python or C++ or some language like that. But for this project, we tried to focus on Ladder because the company that we did the case study, all the production line was in Ladder, all the programs. So we tried to focus in this language.
Okay, thank you.
Weather is good. I am weather fun.
Okay, I will not say nothing about that.
My students know.
Okay, so great, thank you, Jonas. So I think we have more time here. So I'm going to back to the first paper, and I would like to do questions regarding the future works here. What is the what you intended to do for future works here from this point that that you did here in this work?
Yeah, we have a functioning prototype, so there are a lot of experiments that can be conducted based on the work that was developed. The suggestion of Professor Alexandre was very nice. It's a very interesting field of research, providing security and verifying how to enable security both for the communication and for the prototype itself to avoid anyone turning off a single lamppost or the entire network, and that can be a future works. But we also intend to evaluate more about installation costs, so we can better analyze the maximum cost that we can have in a final product, labor costs, for example, and we want to evaluate different dimming strategies to enable more power savings. I think the key word of this work, the thing that we are trying to achieve in developing a prototype for that, it's to enable to save the maximum amount of power for the network, and that's good for everyone paying for the lightning and for the environment itself.
Okay, thank you. Alexandre.
Tudo bem?
Okay, so I'm going to back to the paper, the second paper now. Yago, a last question for you here. How can you? It's possible to I don't know. I was wondering here if it's possible to put something to observe the system dynamics, because here you didn't do this, right?
Yes, I didn't because I haven't time to do this, but it is possible. If we search on the internet, there is some application with Arduino, for example, because he is capable to manipulate matrix. So is one of the solutions. We just need to deliver that data to Arduino in some way, maybe with some conversion with PLC. I'll have to check it, but is one of the solutions that I saw on the internet.
Yeah, just a question, Will. You are testing oil and gas systems. You are testing for us actuators and pressure lines to verify integrity and things like that, right?
Yes.
Do you think that it's possible, for example, I'm thinking about another level of testing. It's to provide the system with expected profiles for the actuators or for the line that you are testing, and automate the process of checking if the test was successful or not. I'm not really sure about the parameters that you are using. You were probably using maximum pressure drop or something like that.
Maybe for a production line as a manufacturer line, it is possible to use profile curves, but in other tests as maintenance and R&D tests, maybe it is not that exact the results. So
Yeah, because you probably have many different types of equipment to test, right?
yes, yes,
Anyone with a specific expected value and something like that.
yeah. When we are working with pressure, usually we have integrity, and the main test is the integrity, and we just need the stabilization of the pressure, so to make sure that it is not leaking. And so it just you have a pressure, and it can decrease or increase in a period of time. So to this type of test, uh, we would need a system to monitoring this. And for other tests, we can have the profile, but it's never the same. So I don't think so. I think it is applicable to a production line, a manufacturing line, but for brown down tests, for R&D tests, for maintenance, it's not that applicable. Maybe, but just checking. It is
All right.
R&D project as this
Thank you.
paper. You're welcome.
So thank you. Um, so moving to the other paper, interoperability, but I don't have more questions. The authors have? No? So I have one last question to Cody. It's good because I can practice English. Thank you.
Great.
So regarding the accuracy and surface quality, what is the better what is the results that achieve more accuracy regarding the surface? So because here we in the last figure of your paper you have three kind of dimensions, right?
Mhm.
Rectangular, ones, linear. So what is the high accuracy and regarding the surface?
So the ones we actually looked at for the surface quality were the linear and angular. The angular specifically. So with those angular faces, a lot of the surface quality issues we have in 3D printing involve those types of faces. We have this thing called the staircase effect. As the angle gets steeper and steeper, the filament has to fill that area up, and so you have lower and lower surface qualities. As you tune your process parameters, you can minimize that a bit, but it's inherent in 3D printing, especially in fused filament fabrication. And so that's kind of how we're dealing with that. We've done experiments in the past using a surface profiler with a stylus that drags across the surface, basically, with a jig to get it parallel. But honestly, in those cases, it's not that useful because of the extreme surface quality issues with angular surfaces. So for those situations, we look at the linear one because you have a flat face, and so your staircase effect is zero. And so if you can minimize the surface quality or maximize surface quality on that vertical face, then it's much easier. In that case, the stylus does work properly. I believe for this one, we were looking mainly at the geometric accuracy, so the stuff you can measure with a caliper, basically. But we do have other surface quality tests that we have done for other things in the past. For this one, the main surface quality metric was visual. Does it look good? Does it look better?
Okay.
Not a quantifiable thing. It can be subjective, but if you look at those pictures, you can see that the layers are more consistent in their heights. They stick out less, because sometimes with the really poor quality ones, you actually have, like, with a surface that should be vertical, you have layers that stick out or push into the part just because of defects in your process parameters. We minimize those visually. But even then, with the stylus tester for surface quality, what they're usually testing for are machine surfaces, and so their tolerances for surface quality are really, really low. And so when you have 0.2 millimeters of deviation, it doesn't necessarily like to pick up on that. It's hard to do surface quality quantifications in 3D printing, especially with these types of machines. If you get into like a DLP or something, it's much easier. But for this one, it's more visual.
Okay, thank you very much.
Sorry, just a curiosity. When a problem that I usually have that I have to take care about, it's when the temperature gradient of the part makes it deform a little bit, and therefore makes some parts being more heated than the others. Did you consider this in the paper? So I'm just curious, because I'm going to read your paper to see what I can do about it.
So the temperature gradients are such a pervasive issue in 3D printing. It's really a big problem. So basically, just so I'm certain, you're talking about when you're printing a part, it starts to curl up or otherwise deform due to those kind of issues. All of our testing was in an open air environment that's kept fairly consistent. The only way I've found to fix that problem in my own experimentation is enclosed chambers with temperature control. If you can minimize the temperature deviations in the environment, you can minimize that shrinkage, or at least keep the shrinkage global once you pull the whole part out, so that you're not cracking, you're not pulling up. We just did a test the other month, I guess. COVID has really screwed with time perception, with a steel infused filament, and the temperature, how the temperature leaves the part basically is incredibly fast. And so in that case, we had to tape it down to the bed while printing, because we didn't have an enclosed environment. But for that issue, enclosed environments, keep your environment as stable as possible in terms of temperature, ideally with a control unit, and that should go away.
Oh, thank you.
Thank you very much. And more questions? So we proceed to the other paper that is from Guilherme. Hi, Guilherme. You're muted? Okay, great. Another question is how do you choose the surface of the slide mold?
I don't understand.
How do you proceed to choose the slide mold surface?
Yeah, I follow I picked I don't know, I understand, but I use it in the sliding surface, the signal of the tracking error. So I calculate the tracking error by means of the difference from the model reference and the control current, and the tracking error, the sliding surface is the proper tracking error. So I try to follow it. But in the super twisting, I use I have another interaction that is consider the derivative of the tracking error. So because the super twisting is smoother than the first order sliding mode, the common sliding mode, and this smoother behavior impacts directly the shattering. So because this will have less tracking error, and consequently we have more performance and more energy quality using the super twisting. The main difference of this control structure is that combines two techniques, and both are adaptive. It's not very common to see super twisting and sliding mode adaptive. And
Okay, yeah. I was doing this question because I know that the choice of the surface is very important in the first part of the controller and the slide mode controller. So you're using super twisting and the first order. So I was thinking about this. So thank you.
Yes. Okay. Thank you.
Alexandre, authors, you have questions? Okay, so to the last paper here, that from Vitor. I have no questions. I am very satisfied with your presentation, with your paper. Just want to congratulate you once again. We don't have more questions on YouTube. So I think we can end the session, Alexandre.
No problem.
No problem. Okay, so thank you all the authors to attend this conference, and I hope you attend the next one in Induscon. So thank you very much, and thank you for audience here.
Okay.
Bye. Valeu.
Bye.
Okay, thank you. Goodbye.
Thank you. Goodbye.
Thank you. Good afternoon. Bye.